Hello everyone, welcome back to my YouTube channel. Myself Pratham, and in today's video we are going to understand one of the most important concept in computer networks, that is DNS, also known as domain name system. Now think of this: whenever you type something like google.com or youtube.com in the browser, how do system know where to go? So this is where exactly DNS pitches in. So in simple terms, the DNS is like a phone book of the internet. It converts the human readable names into machine readable IP address. So this is what we are going to say in this video. I'll explain you what is DNS, why it exists, and how it works step by step. And even I'll show you some practical commands in the command prompts. So let's get started. So first thing is, what is DNS? So DNS stands for domain name system. It basically a system that helps the computer to find each other on the internet. So like as mentioned, if you want to type google.com, this DNS is the thing where it finds the IP address and take you to that take you to that browser. So if you type youtube.com, that is the DNS thing where it checks the IP address and it locates you to that uh, specific browser. So we will check this using a command later. I'll show you. So before that, first understand the concept. Now, now example, you can remember the name Google YouTube, but you cannot remember the name IP address like 142.255.255.255. That is why the DNS is introduced, and it translates the IP address into the name. Okay, this is how it works. So in simple case, you can just note it as you have a contact number, and you just type the name. So you search the name and you get the number of that. So same way, the DNS is the internet phone book for the it's the internet's address book. Yeah. Now next we can go. Now you might be thinking, why do we need DNS? There is actually several important reasons. The first thing is human readability. We can easily remember the names like YouTube, Yahoo, Google, but not the IP address. That is why this is there. Second, the flexibility. If a website changes its server, the IP changes, but the domain name stays same. That is why this is there. Third point is speed using the caching. DNS stores the results locally, so next time it loads instantly. So there is no need to reload every time. So it stores the caches and next time it loads instantly. So that is why it is there. And then fourth one, load balancing. One domain can point to multiple servers to handle traffic, so there won't be a load balancing issue in this DNS. So because it is pointing to multiple servers to handle the traffic. Fifth one, security with DNS SEC. It prevents attack like fake DNS responses. Suppose if there is any fake IP addresses, it prevents from those attacks. Then decentralization. DNS is not controlled by one server, it is globally distributed. Let's say there is one server which is kept in India, and it doesn't depend on this. There are many servers. One is kept in India, one is kept in America, and one is kept in Japan, and one is kept in some other countries. So it doesn't depend on a single server in a single place. So that is called decentralization. So overall, DNS makes an internet usable, fast, and scalable. That is why the DNS exists. So if they ask you what is the architecture of the DNS, you can just see here. Yeah, this is the browser first step where you type your google.com and it stores in the local cache, and this is a recursive solver where your system has some ISP dot like 8.8.8, and then we have a root server, top level authority of the DNS, which is the top level authority. Then we have a TLD server which handles the domains like .com, .in, .org. So this TLD server is the thing which handles all this .net like that thing. So next we have authoritative server, this is where the actual IP address is stored. So the request flows through step by step to these layers until the IP is found. So here is where the real IP is found. Okay, make the note of this step. And then this is from here only this is found, and from this it fetches the browser. So this is a simple architecture. You can make a note of this and it will be very useful. Then next we have how DNS works. So we can go step by step. For example, let's say you type www.google.com. Your system first checks the browser cache and OS cache. Next, if the request, if it is not found, it sends the request to DNS resolver. Resolver asks the root server that who handles the .com. So .com is handled by, as mentioned, TLD server. So TLD server says go to the YouTube name server. Then TLD authoritative server gives the final IP address, like this is the IP address of the YouTube. Then IP address is returned and then it is stored in the cache for future use. Then from that IP address it connects the YouTube. That's all. It's very simple. So let's say again you enter your URL www.com in your browser. It checks your browser cache and OS cache. Then using that cache it goes to the DNS resolver asking, this is something they are asking, and from there it goes to, using the .com, it goes to the TLD server. TLD server sees the request and then it says it's a YouTube name server, go to authoritative server, where the authoritative server gives the final IP address for this YouTube and it stores the cache for the future use. And then using that IP, the browser is loaded on your screen. Next, we have these DNS commands. I have already pasted the commands in the PPT. You can just refer this and you can also try it in your command prompt, which we will also try in upcoming after this, in upcoming slides. After this we'll do a practical session, how what is DNA and how does it works. I'll tell you everything. Now this is the DNS commands which you can try in your terminal anytime. So I have kept this alive for one screen. And next I'll go to the next slide, that is DNS record types. So there is something called a record, that maps the domain. What is a record? Maps domain means it only reads IPv4 address. So make sure this. Then there is AAAA record, that maps to IPv6. So that there are two IP addresses which in your command prompt, if you type ipconfig, there is no space, just type ipconfig, you get two addresses, that is IPv4 and IPv6. So that is with respect to a record and AAAA record. Then we have CNAME, alias of another domain. These are called alias of another domain. Then we have MX record used for mail routing, and we have a NS record specifies the DNS server, and we have a TXT record used for verification and security. Then PTR record reverses the DNS to IP to domain. So we have these kinds of addresses in our DNS. Then we have live demo, which already I mentioned in the previous script. Same way, if you are using a Linux terminal, you can use these types of command. I've just again given that and you can utilize that later. So it's similar to Windows. So we are using Windows. Suppose if you have the Mac or Linux based OS, you can just use these things. Then the final thing is we have DNS caching and TTL. Now let's talk about caching. DNS doesn't repeat the full process every time. It stores the result in some cache. It is controlled by something called TTL. What is TTL? Time to live. TTL means how long DNS record is stored. So we have two types of TTL, that is high TTL and low TTL. High TTL have very fewer queries and low TTL have faster updates. Okay, now caching happens at multiple levels. The first level is browser caching, second level is OS caching, third level is router caching, and fourth level is ISP caching, that is 8.8.8.8, which you will see on your ipconfig screens. So because of the caching, DNS looks super fast. Okay, then this is a summary what we looked from the first screen to last screen. So let's summarize quickly. DNS is a phone book. What is DNS? It is a phone book of the internet. It converts the domain name to the IP addresses. Next, it uses a hierarchical system. It works in milliseconds. It improves the speed using the caching, and it has a DNS security where it prevents from the fake entries. Okay, so these are the things which we have done. So now let's go to the practical session where we'll be checking the same. So we have a command prompt here. So in the command prompt, just type. Now what we'll do is similar how DNS works, we'll see. So how it works. So first thing is we have to type something ns lookup google.com. So I'm calling the name here, I'm not calling any IP addresses. So how DNS works, once I click on enter, you can see the server is unknown because that is security purpose they have given unknown, but the address where it is showed it is shown, and then the name Google, then addresses for non-authoritative answer. So if you ping this, ping www.google.com, so you guess you get this answer from TTL, time to live. So what we saw, what I explained you there, this is the time to live server, and this is where it is stored. So you can see. Okay, so we are getting the reply from this. So if we are getting the reply from this, so what did we do? It sent the synchronization and we get the acknowledgement and we are able to access it. So first thing is it is done, and then next we'll go for checking the mail server with all the servers like MX record. What I mentioned, MX record means there are multiple servers which is there. So let's check that. ns lookup hyphen type is equal to mx gmail.com. Let's check for gmail.com. so you can see next type. Okay, you can see the server type and you can see this. Okay, and one more thing what we can do is we can also type this ping youtube.com. Check if this is there. So you can see each has a different address and different TTL. There is nothing same, so each thing has different addresses and different TTL. So that is where we are getting the response. So if you have done this is the thing where how DNS works. We have gone through the full workflow of the DNS. If you like this video, like, share and subscribe.